That's better. All right, so we have ellipses. I'm just going to write down. We had something like, for an ellipse, we had something like x squared over a squared plus y squared over b squared equals 1. And this was the equation of an ellipse. In the equation of an ellipse, what did A tell us? A was a distance. Distance from where to who? The vertex. A gave us a distance from center to vertex. How about B? Center to covertex. And C? Center to focus. And we had a little formula. C squared equals A squared minus B squared. Ellipses have almost, or hyperbolas I mean, have almost all the same information. Now this ellipse that I drew here, that I wrote here, x squared over a squared plus y squared over b squared equals 1. Which way would this ellipse go? Is this one a long and not very tall, or is this one tall and not very long? Long but not very tall. How do you know this one's long but not very tall? Because the a was under the x. All right, a hyperbola, we have very similar stuff. First off, the equation is almost exactly the same. The only difference is we have a minus in the middle. X squared over a squared minus y squared over b squared equals 1. And we're going to have a lot of the same information. A still gives the distance from the center to the vertex. B, I don't know how to describe it, so I'm just going to put question marks, and in a minute we'll draw some pictures and you'll understand what it is. Because there's no covertex on a hyperbola. But we'll talk about what B is used for here in a minute. No easy way to describe it in words, as far as I know. C is still the distance from center to focus. And then we have a little equation, a very familiar looking equation. C squared equals a squared plus b squared. So when you're dealing with hyperbolas, the little formula is exactly the Pythagorean theorem that you're used to dealing with. Yes. Yeah, and you get a triangle which gives you exactly that relationship, and we'll see that in just a second here. All right, so this hyperbola, when x is positive, the hyperbola will open right and left. But where's the center for this hyperbola? X squared over a squared minus y squared over b squared equals 1. Where's the center? 0, 0. And how would I have something not centered at 0, 0? I'd have some numbers. I'd have like an x minus 2 and a y plus 1. All right. So this one has center at the origin. So it's centered right here. And when the x is positive, it's going to open right and left. When's it going to open up and down? When x is negative and y is therefore positive. All right. So we have our vertex is going to be here and here, 2 vertices. So again, this distance will be A. And then our focus is out here a little bit further. So for a hyperbola, the focus is bigger than the length of the major axis. So this distance will be C. And then our hyperbola is going to look something like this. you get two things that look kind of like parabolas, although they're not really parabolas, they just kind of look that way. And then what you have is B. So B is going to be, I didn't draw my pictures very well. We'll get B is right about here. So this length is going to be B. And what happens if you take this point right here, A, height of B, my graphs are very poorly drawn, you get asymptotes. And they should be straight lines, but mine are not straight lines. They look terrible. I should have drawn the asymptotes first. The slope of this asymptote should be rise over run, so it should be B over A. So the asymptotes have equations y equals plus or minus B over A. So that's where the B number comes in. The B number comes in determining the asymptotes on the graph. B is this number B. So B is, whatever B is, you go that far up. So that's the rise, that's B. And then this point over here, this asymptote should go through this point right here, which is supposed to be the point A comma B, but so maybe, I don't know, my graphs aren't drawn very good, it's the problem. So we'll do another one and we'll make it look better, and you'll see how it should work. All right, so for example, let's try this one. Determine the vertices, the foci, and asymptotes of each of the following. Also sketch a rough graph. I should also said find the center, but that's pretty obvious. What's the center for this one? 0, 0. All right, so where are the vertices? Well, for this one, what's the A number? A is 2, because this number down here on bottom, this is A squared. All right, that's for ellipses. For ellipses, A is the one that goes with the bigger one. For hyperbolas, A is always the one that goes with the positive thing. So A always goes with the positive, B always goes with the negative. So slightly different. So in this case, the vertices are 2, 0 and negative 2, 0. How about the foci? Well, what do we need to know in order to find the foci? Which letter gives us the distance from the center to the focus? C, so we need the C number. Do we know the C number? Well, we don't exactly know it, but we can figure it out pretty easily, can't we? The little formula is C squared equals A squared plus B squared. So in this case, that's 4 plus 16, which is 20. So C is square root of 20. So we're going to have square root of 20 comma 0 and negative square root of 20 comma 0. And then our asymptotes. Y equals plus or minus B over A. What's the B number? 4. And the A number? 2, so that's plus or minus 2. X. I should have X's in front of them. Y equals plus or minus 2x. I have an X to be an asymptote to be an equation. All right, so here's our picture. We have our vertices at 2, 0, and negative 2, 0. Then I like to draw the asymptotes. So the asymptotes, I go up 2 over 1. So this is y equals 2x, and then y equals negative 2x would be this way. Say that again. Because my slope is 2. So I thought of 2 as being 2 over 1. So it tells me to go up 2 over 1. Up 2 over 1. All right, so here's what my hyperbolas have to look like. Go ahead. They really should be dotted. Asymptotes should always be dotted. It's not horribly wrong. It's not like the, asymptote police are going to come arrest you or anything. All right, so then the hyperbolas should go through that point and then get close to those dotted lines. So hyperbolas look something like that. Questions on that one? We should probably label the foci. They would be over here somewhere, right? Square root of 20. About how big is square root of 20? 4.5-ish. It's certainly between 4 and 5 because 4 squared would be 16 and 5 squared would be 25. So our foci are out about here somewhere. Square root of 20 comma 0 and negative square root of 20 comma 0. Correct. Hyperbolas never cross those dotted lines. What's the significance of the foci? What was the significance of the foci for an ellipse? Do you remember? It wasn't halfway between. In an ellipse, when you have an ellipse and you have the two foci, if you pick any point on the ellipse, this distance plus that distance is always the same. So if I were to pick this point, that distance plus that distance would have to be the same as that one plus that one. So that was the importance of the foci in an ellipse. On a parabola, you had a focus and you had a directrix, and this distance and that distance were supposed to be the same. They don't look at, so that's not a very good picture there. So that was the importance of the focus on a parabola. So what is it on a hyperbola? You want to know the truth? I don't remember. But it has to do something like that. I think it's something like, I'd have to look it up in the book, but I don't remember exactly what it is. But it has to do with a distance sort of thing. If you pick a point on here, the distance from here to the focus is maybe the distance from here to the center or something like that. I forget exactly what it is for a hyperbola, but it's something along those lines. Okay? Don't remember exactly what it is for a hyperbola. All right, so let's take a look at B. And I can see I'm going to need more space to draw here. B, we have y squared over 9 minus x squared equals 1. All right, so what's the first difference here? It opens up and down. How do you know it opens up and down? The x is negative, the y is positive. Whichever one is positive, that tells you which way it opens. When y is positive, y goes up and down, so it opens up and down. When x is positive, x goes right and left, so it opens right and left. All right, so this case, what's our center? 0, 0, 0. Where are our foci? 0, comma 3, and 0, comma negative 3. So in this case, A is the number 3. A is always the number under the positive one for a hyperbola. Oh, I'm sorry, you're absolutely right. Those 2 points are the vertices, not the foci. Thank you. What's the B number? 1, because you could think of this as over 1. So B is 1. So that means the C number, C squared, is going to be A squared plus B squared. That's going to be 9 plus 1, which is 10. So C is the square root of 10. Now we can write our foci down. Do it correctly this time. What are the foci? Loud over there today. 0 root 10 and 0 negative root 10. I'm going to write it as 0 plus or minus root 10. Sure, you can write it. And same with the vertices. You could have written the vertices as 0 plus or minus 3. That would be fine also. You have to be careful when you're not centered at the origin. When you're not centered at the origin, you can't write it that way. But centered at the origin, it looks like. Alright, so again, drawing our picture here. We have our vertices at 3, 0, comma 3. And 0, comma negative 3. Alright, our B number is 1. So here's 1 and here's negative 1. So our lines are going to go through those points right there. Go this way. So this is our A number, this is our B number. So our lines go through that. What you see in the book is they draw a box like this. And your asymptotes go through the corners of the box. So what's the equation of this line right here? Goes through 0, 0, and it goes through the point 1, comma 3. So what's the equation of that line? Y equals 3x. Why is it y equals 3x? You go up 3 over 1. So the asymptotes are y equals 3x. And how about the other one? What's the equation of the other one? Y equals negative 3x. So y equals plus or minus 3x. And then again, our hyperbola would go through the vertices, get close to those asymptotes. Oops, I went over that one. Broke the rules. And finally, our foci. Square root of 10. Square root of 10 is just a teeny tiny little bit bigger than 3, isn't it? So they're right close there. 0, comma square root of 10. 0, comma negative square root of 10. Ah, excellent question. Why didn't I do y equals b over a? How come this? What did I do this time? I did a over b, didn't I? All right. I was hoping somebody would catch that. So your formulas turn out to be slightly different. When your hyperbola goes left and right, like this one does, your asymptotes are b over ax. When your hyperbola goes up and down, like this one does, then it turns out to be x. So they change slightly. Now, personally, I tend to not remember the formulas. I tend to get it from the picture. So I like to draw the little box like the books does, and then I just figure out what the equations have to be. Some people like memorizing the little formulas. Either way is good by me. Alright, next one we have. What do we have? 4y squared minus 9x squared equals 144. What's wrong with that one? It's got numbers in front here, and it's got 144 over there. So how do we fix it? This number right here has to be the number 1, doesn't it? That's always got to be a 1 right there. So we're going to divide by 144. Y squared over. What's 4 divided by 144? 1 over 36. Minus. What's 9 divided by 144? Over 16. Alright, so that one first we have to rewrite it slightly. We have to rewrite it that way. Not that bad. What's the A number? 6. What's the B number? 4. What's the C number? Square root of 52. How'd you get square root of 52 so fast? You add A squared plus B squared. 36 and 16 makes 52. And then you'd have to take the square root of it. That's correct. So you don't really need to write down the formula if you don't want to. C squared equals A squared plus B squared. This one going up and down, or is it going left and right? Up and down. How do you know it's up and down? Because the y is positive or the x is negative. You can say it both ways. I tend to go because the y is positive. Alright, so starting to draw my picture here. I have 0, 6. And 0, negative 6. And then again, to find the asymptotes, here's what I tend to do. I use the B number. B is 4. So I come over here to 4 and over here to negative 4. And I come up to here and I draw this box. So that's what the B number does for me. My asymptotes, again, go diagonally through the box, through those corners and through those corners. So draw those in. So what are those equations? Y equals, well, really the only thing we need to know is the slope. What's the slope? The rise is 6 and the run is 4. So the slope is 6/4, which I would write as 3/2. So the asymptotes are plus and minus 3/2 x. Vertices we already found. 0, plus and minus 6. The foci we already found. 0, plus and minus square root of 52. All that's left to do is draw the picture. That and like that. Down here, like so, and like so. Oh boy. Gosh, my asymptote broke the rules. And finally, I guess I should draw the foci in. 0 square root of 52. 0 negative square root of 52. Questions on that one? A is always under whichever one is positive. For an ellipse, A is always whichever one is bigger. So very slight difference there. Here, size doesn't matter, A or B. Which matters is which one's positive, which one's negative. Record button's on now. And there's my other asymptote. Now, here's the hardest part. What is the equation of these asymptotes? 4 over 3x. Plus or minus 4 over 3x. Close. Not quite. The problem with plus or minus 4 over 3x, where's the y-intercept of plus or minus 4/3 x? It's at the origin. Do these have y-intercept at the origin? No. The slope is plus or minus 4/3. All right, so here's the easy way to do it. It's y plus 2 equals plus or minus 4/3 times x minus 1. Where did the plus 2 come from and where did the minus 1 come from? It's the center because they go through that point, don't they? So what I used is the formula y minus y1 equals m times x minus x1, where I know they go through that point. So I used the negative 2 for the y1 number, I used the 1 for the x1 number, and then I used my slope. From looking at the picture, I can see my slope is 4/3. Well, that was the one thing I don't think I saw anybody have correct as I walked around. Lots of people had y equals plus or minus 4/3 x. But you didn't recognize it. Oh, that's not my intercept anymore, 0, 0. All right, so you want to use that. All right, other than that, people did very well, getting very close. So, so. So. All right, just a couple minutes left here. I'm going to skip F, but can somebody tell me what you would have to do on F? Do what? Factoring, unfortunately, doesn't quite work. You have to complete the square. So the y's are okay. You would have to complete the square right there on the x's. Oh, I'll do it real quickly, I suppose. It would be x squared minus 2x plus, what's the magic number I would have to add? One, because I take the negative 2 in the middle, I divide it by 2 and I square it. That's 1. So I would have to write this as x minus 1 squared minus 4y squared equals 4. And then you would divide both sides by 4 and you would have it exactly in the form that you need. All right, how about question 2 here? Again, question 2, we're going the other way. Now I'm giving you information and I want the equation. So I give you the foci and I give you the vertices. All right, so what's the center? How do you know the center is 0, 0? It's got to be halfway between the vertices or halfway between the foci. All right, so center is 0, 0. Is this one going left and right, or is it going up and down? How do you know it's going left and right? Because the x's are the numbers changing, not the y's. That's correct. So it has to look like x squared over a squared plus y squared over b squared equals 1. Do I know the a number? The a number is 3. How do you know the a number is 3? Because the vertices are plus and minus 3. That should be a minus there. Oh, mackerel, that's a minus there. Do I know the B number? No. But can I find the B number? Yes. How can I find the B number? C squared equals A squared plus B squared. So I have 5 squared equals 3 squared plus B squared. Without solving that, does anybody know the answer? 4. How do you know it's 4? It's a 3, 4, 5 triangle. 3, 4, 5 Pythagorean triple. So y squared over 16 equals 1. Next one. Also center at the origin. What's the only difference with this one? It's going up and down, so it's y squared over a squared minus, I want to do plus, squared over b squared equals 1. I can move it up so you can see what I'm writing, sure. That always helps. A number this time. A number is 1. B number this time. Well, I don't know yet. I got to figure it out. C squared equals A squared plus B squared. So C is in number 2, so that's 4 equals 1 plus B squared. So B is? Well, B squared is 3, right? And that's really what we need there anyway. I don't really need to know the B number. What I really need to know is the B squared number. All right, how about the last one? Center is still origin. I know the A number. What's the A number? 6. Up or down, left or right? Up and down, so it's y squared over a squared minus, I have a plus again, x squared over b squared is 1. So y squared over 36 minus x squared over something equals 1. How am I going to figure out the B number? All right, so again, I think I would, again, draw a really quick picture here. This is 0,6. My asymptotes, wouldn't it be 3? I don't think it's 3. My asymptotes look like this. Y equals 1/3 x and y equals negative 1/3 x. And so remember what has to happen. This point right here has to be the point B comma A. So, what's the slope of this line? It's A over B. So A over B has to be 1/3 because the slope is 1/3. But we know the A number. A is 6. So B has to be 18. B has to be 18 in this problem. So that has to be 18 squared, whatever that is, down there on the bottom. How did I get 18? I knew the slope of this line was 1/3, and so the slope of this line is rise over run, which is the y number over the x number. So A over B had to be 1 over 3. But we know A is the number 6. So 6 over B has to be 1 over 3. So what number B do I plug in there to reduce to get a 1/3? It has to be 18. Okay?